Hi everyone, this is YouTube channel Math Insights. In this video, we are going to solve some problems based on the topics which were discussed in the previous video, that are remainder theorem, factor theorem, and how to factorize polynomials by using identities. If you want that video, you may find that video. I have given the link in the description. Shall we start? If you see the first problem, it says that find the remainder when x cube plus 3x square plus 3x plus 1 is divided by 5 plus 2x. They have given a polynomial and they have given another polynomial, and they are asking to divide the first polynomial with the second polynomial. Then you have to find the remainder by using remainder theorem. Let you have to assume the given polynomial as p of x. I am writing it as p of x. P of x is equals to x cube plus 3x square plus 3x plus 1. And they are asking you have to find the remainder when it is divided by 5 plus 2x. In that you have to find the x value. That is when 5 plus 2x is equals to 0, 2x will become minus 5. When plus 5 goes to other side, that will become minus 5. Then x will become minus 5 by 2. Therefore, you have to substitute x is equals to minus 5 by 2 in p of x. Then you will get the remainder. That means remainder is equals to p of minus 5 by 2. That means wherever x is there, I am substituting x is equals to minus 5 by 2. Similarly, in the polynomial also, you have to substitute x is equals to minus 5 by 2 and find the value of the polynomial. That will become the remainder. Okay, so x cube means minus 5 by 2 whole cube plus 3 into minus 5 by 2 whole square plus 3 into minus 5 by 2 plus 1. Very simple. Wherever x is there, I substituted x is equals to minus 5 by 2. Then this will become minus is multiplied 3 times. Then you will get minus again. 5 cube means 5 into 5 3 times. That will become 125. Similarly, 2 cube, that is 8. Plus, see, 3 into minus 5 by 2 whole square. This minus will become plus when it is multiplied by 2. Why? Because 2 is there, power 2 is there, therefore it is to be multiplied 2 times. Therefore, you will not get back minus again. Again, 5 square, 5 into 5 will become 25. Similarly, this is 2 square. 2 square means 4. And this plus into minus will become minus. 3 5s are 15 by 2 plus 1. So if you don't have anything here, you may write it as 1. Therefore, you have to take LCM for all these denominators and it will become 8. LCM is the number which is divisible by all these numbers. Okay. So when 8 is multiplied by 8, the quotient is 1. With that quotient, you have to multiply this number. Therefore, you will get minus 25 again plus. Actually, this is 25 into 3, 75. And if you divide this 8 with 4, the quotient is 2. And you have to multiply this 75 with 2. 75 into 2 will become 150. Okay. And minus, when 8 is divided by with 2, it divides 4 times. 4 into 15, 15 4s are 60. Plus, when you divide this 8 with 1, your quotient is 8. 8 into 1 is 8. Therefore, we have to do simplification. See, minus 125 minus 160, that is minus 185. And plus 150 plus 8, that is plus 158 by 8. That implies to see minus 185 plus 150. This will become 27. Actually minus 27. Why? Because bigger number is bearing minus, therefore this is minus 27 by 8. This is P of minus 5 by 2. Therefore remainder when the given polynomial is divided by 5 plus 2x, the remainder is minus 27 by 8 as per the remainder theorem. If you see the second problem says that find the remainder when the given polynomial is divided by x minus p. This is also same as the first question, but instead of one constant they have given p. Therefore let the given polynomial be named as p of x, that is p of x is equals to x cube minus px square plus 6x minus p. After assuming like that, you have to find the value of x with which you are going to divide the given polynomial. So x minus p, when x minus p is equals to 0, then your x will become p. That means you have to keep x is equals to p in the given polynomial and you will get some value, that is the remainder. So therefore remainder is equals to p of p, that is equals to, in LHS I have substituted x is equals to p, and also in RHS you have to substitute x is equals to p. Whatever the value you will get, that will become the remainder, that is x cube means, so p cube minus p into again x square means p whole square plus 6 into p minus p. See, this will become p cube minus p into p square, that will become minus p cube plus 6p minus p. This minus p cube plus p cube will get cancelled. Why? Because they have bearing the opposite signs, and also plus 6p minus p will become 5p. Therefore this is the remainder when the given polynomial is divided by x minus p. If you come to the third problem, in the third problem they have given two polynomials and they are saying that this x minus 2 when divided leaving the same remainder, then they have given one unknown, that is a. They are asking the value of a when these two polynomials leaves the same remainder when it is divided by x minus 2. This is also very simple as we did in the previous problems. I am letting as usual, since they have given two polynomials, therefore we have to assume the given polynomials as p of x and q of x. I am letting p of x as 2x cube plus ax square plus 3x minus 5, and the second polynomial I am assuming it as q of x cube plus x square plus x square minus 4x plus a. After assuming like that, you have to use the remainder theorem and find the remainder when the given polynomials are divided by x minus 2. When any polynomial is divided by x minus 2, you have to substitute x is equals to 2 and find the remainder. Okay, when x minus 2 is equals to 0, then x will become 2. Therefore remainder, the first one, remainders are p of 2 and q of 2. When you put x is equals to 2 in p of x, you will get some value for this, and also when you substitute x is equals to 2, you will get another value for q of x. They are saying that those two remainders are equal. We will equal them and we will find the value of the unknown quantity, that is a. So p of 2 means 2 into 2 cube plus a into 2 square plus 3 into 2 minus 5. This is the remainder when p of x is divided by this x minus 2. They are saying that this remainder is equal to the remainder when x minus 2 is divided by q of x. So in this case it will become 2 cube plus 2 square minus 4 into 2 plus a. So you will get the answer. See, 2 cube means 8. 8 2s are 16 plus this is 2 square. 2 square means 4. 4 into a will become 4a plus 3 2s are 6 minus 5 is equals to, this is 2 cube means 8 plus 2 square is 4 minus 4, okay, plus a. Here you may cancel this minus 4 plus 4 and these 16 plus 6 22. 22 minus 5. 22 minus 5 will become plus 17. 17 plus 4a is equals to 8 plus a. Okay, I am taking this plus a to this side and this number is going to that side. Therefore 4a plus a will become minus a and 8 will be there, and this my 17 goes to other side, its sign will change, minus 17. Therefore this 4a minus a is 3a, that is equals to, this is minus 9. Therefore a value will become minus 9 by 3, that is 3 1s are 3 3s are minus 3. Therefore a is equals to minus 3. So in this way you may calculate whatever the unknown they have put in the given polynomials. Coming to fourth one. Fourth one says when a polynomial is divided by x minus 2 leaves remainder 2 and x plus 2 leaves remainder minus 2. Then find the values of a and b. This is somewhat different than the previous problems. They have given a polynomial and they are dividing that polynomial with different divisors and they are saying different remainders. Then you have to find the values of the unknown quantities a and b. So I am assuming as usual the given polynomial as p of x. P of x is equals to 2x cube plus 3x square plus ax plus b. After assuming that, I will find the remainder when this polynomial is divided by x minus 2. That means x will become 2. Therefore remainder is equals to, remainder when x minus 2 is equals to 0, that is x is equals to 2. Therefore p of 2 is equals to, I am placing x is equals to 2 in the given polynomial, 2 into 2 cube plus 3 into 2 square plus a into 2 plus b. Okay, that is equals to, p of 2 is equals to 2 cube is 8, 8 2s are 16 plus 2 square is 4, 4 3s are 12 plus 2 into a 2a plus b. That is equals to 16 plus 12 will become 28 plus 2a plus b. That is p of 2. P of 2 is nothing but remainder. But they have already given that what is the remainder when this x minus 2 is divided the given polynomial. That is 2. Therefore remainder already given 2, that is 2 is equals to 28 plus 2a plus b. That implies 2a plus b is equals to, when this 28 comes to this side it will become minus 28. Minus 28 plus 2 will become minus 26. Okay, minus 26. Let it be equation number 1. Similarly, you have to find the remainder when the given polynomial is divided with x plus 2. Therefore remainder is equals to, remainder when p of x is divided by x plus 2. That means you have to place x is equals to minus 2. I am placing p of minus 2, that is equals to, I am placing minus 2 in place of x. Therefore 2 into minus 2 whole cube plus 3 into minus 2 whole square plus a into minus 2 plus b. this is the remainder, but already they have given remainder as -2. Therefore -2 is equals to, this is -2 whole cube will become -8. Why? Because minus is multiplying add number of times, therefore it will become again minus. So 2 cube is 8, 8 2s are 16, -16. Okay, and this is -2 whole square. -2 whole square will become +4. 4 into 3, 4 3s are 12, plus 12. Okay, and this is -2a plus b. -2 is equals to -16 plus 12, that is -4, -2a plus b. Now I will take this -4 to this side, then it will become +4. Therefore +4 minus 2 means 4 minus 2, it will become 2. Therefore -2a plus b is equals to 2. Let this equation as 2. You have two equations now, 1 and 2. By using these two equations, whether if you add those equations or subtract those equations, you will get cancel one unknown quantity, then you will get another unknown quantity. After finding the first unknown quantity, if you substitute in either of the given equations, you will get the second unknown quantity. Okay, I will erase some part of this solution, then I will solve for a and b. From 1 and 2, I am writing from 1 and 2. See, I am writing 1. This is 2a plus b is equals to -26 minus 2a, second one, plus b is equals to, this is 2. See, on addition, this 2a minus 2a will get cancelled. Therefore you will have plus b will become 2b, that is -26 plus 2 will become -24. Therefore you will get b value as -12. After getting b value as -12, you may substitute the b value either in equation 1 or equation 2. You will get a value. So in this way you may find the values of a and b. If you see the fifth problem, find the value of k if 2x minus 3 is a factor of 2x cube minus 9x square plus x plus k. See, this problem is based on the factor theorem. So far we have solved the problems based on remainder theorem. Now you are going to solve the problems based on factor theorem. The main difference between remainder theorem and factor theorem is, in the remainder theorem you will get something as your remainder, but in factor theorem you will get 0 as your remainder. If you will get 0 remainder, then the divisor will become factor of the given polynomial. This is the concept of factor theorem. So they are clearly saying find the value of k if a factor. If you see the term factor, then you have to understand that the remainder is 0. Therefore I am letting, as usual, let p of x is equals to, see, 2x cube minus 9x square plus x plus k. They are saying that 2x minus 3 is a factor. That means if you substitute x is equals to 3 by 2, the remainder is 0. As per the problem, 2x minus 3 is factor of p of x. That means if you substitute x is equals to 3 by 2, p of 3 by 2 is equals to 0. As that is a factor of the given polynomial, therefore the remainder is 0. Then only we will say that that is a factor. Therefore 2 into, in the place of x, I am substituting 3 by 2 whole cube minus 9 into 3 by 2 whole square plus 3 by 2 plus k is equals to 0. Factor theorem. Therefore this is 2 into 3 cube. 3 is multiplied 3 times, that will become 27 by, again 2 cube will become 8, minus 9 into 3 square is 9, 2 square is 4, plus 3 by 2 plus k by 1 is equals to 0. If you take LCM for all these numbers, you will get 8. So by taking 8 as our LCM, if you divide the LCM with 8, the quotient is 1. So 1 into 27 by 2, that will 27 by 2, that is 54, right? 54 minus, again if you divide this 8 with 4, you will get 2 as your quotient, then multiply this 9 into 9 with that 2. 9 9s are 81. 81 into 2, 162. 162 plus, if you divide 8 with 2, you will get 4 as your quotient. 4 into 3 will become 12 plus, if you divide 8 with 1, the quotient is 8. 8 into k, 8k is equals to 0. And cross multiplication, 8 into 0 will become 0. Therefore, 54 minus 162 plus 12 plus 8k is equals to 0. See, in this case, you have to subtract this plus 12 from minus 162. Therefore, 54 minus 150 plus 8k is equals to 0. So 54 minus 150, that will become minus 96. Minus 96 plus 8k is equals to 0. Therefore, minus 96 goes to that side, that will become plus 96. Therefore, 8k is equals to 96. K is equals to 96 by 8. 8 ones are 8 twos are. Therefore, k is equals to 12. So, in this way, you may calculate the value of k by using factor theorem. Coming to sixth question. Sixth question, it is very easy. They have given two quadratic polynomials and they are asking to factorize. You know, the factors of any polynomial depends on its degree. So, the degree of the first quadratic polynomial is 2, and in this case also 2. Therefore, you have to factorize this polynomial and find the two factors, and in this case also have to follow same method. I will solve this one basing on the same concepts. You have to solve this also. Okay, so 6x square plus 19x plus 15, this is the polynomial. So I said how to solve the quadratic polynomial by using factor theorem. I explained you how to solve this quadratic polynomial, how to find factors for this quadratic polynomial. See, I said that you have to multiply this constant and the coefficient of x square, that is 6 into 15, that is equals to 15 6 are 90. So after finding the product of the constant and coefficient of x square, you have to find the factors of this number in such way that if you add or subtract those pair of factors, you have to get this 19. See, I am finding possible factors for 90. That means 1 comma 90 maybe, and also 6 comma 15 comma 9 comma 10 also. So in these possible factors, I have to check where I get this 19 when subtracted or added. See, when added you will get 90, and also subtraction you will not get 19. So in this case also 15 plus 6 will become 21, and also 15 minus 6 is actually 9, you will not get. But in this case, if you add 9 and 10, you will get 19, and also if you multiply 9 into 10, you will get 19. Therefore, I will split this 19x as 6x square. I am splitting 19x as 9x plus 10x plus 15. Then I have 4 terms in the polynomial instead of 3, and I will search for any common factor from the first two, if you observe, x is common. Along with x, you have 3 as your common factor. Therefore, I am taking 3x as my common factor. 3 2s are 6 and 1x is already placed outside the bracket. You will have 1x inside the bracket, plus is there, plus 3 3s are 9 and already this x is outside the bracket. Therefore, I am closing the bracket. Similarly, you have to search any common factor is there between the two last terms. That is 5 is there, x is not there. If you take 5 2s are 10 and x plus 5 3s are. So you have now two terms. This is the first one and second one. In these two terms, again you have a common factor, that is 2x plus 3, 2x plus 3. If you take 2x plus 3, then you have 3x here and plus 5 here. So these are the two factors. Factors means if you multiply any two, you have to get back the original product. That is 2x plus 1 is one factor and 3x plus 5 is another factor. In the similar manner, you may find the factors for the second polynomial also. If you see the seventh question, factorize this polynomial. See, if you observe the degree of the polynomial, it is 3. That means this polynomial will have 3 factors. In the previous problem, the degree of the quadratic polynomial is 2 and hence the factors for that polynomial is only 2. Now in this case degree is 3, therefore you have to find 3 factors for it. Let us assume the given polynomial as p of x. P of x, this is question number 7. P of x is equals to x cube minus 23x square plus 142x minus 120. See, in this case you have to remember two principles. First one is, when the coefficients of all powers of x in the polynomial are 0, when the coefficients of all powers of x, see, even powers, odd powers, you have to take coefficients of all powers. That is, see, this is coefficient of this x cube is 1, coefficient of x square is minus 23, coefficient of x is plus 142, coefficient of x power 0 will be there actually, x power 0 is minus 120. If you do the simplification, you have to get 0. See, 1 plus 142, 143 plus 143 minus 23 minus 120 minus 143. So you will get 0. Then x minus 1 is the factor of the given polynomial. Again I am repeating, if sum of all coefficients of a polynomial are 0, I am taking all the coefficients. The coefficient of x cube minus 1, 23 minus 1 plus 142 minus 120, I am getting 0. Therefore x minus 1 is a factor of x, a factor of p of x. You may write like that. So if you find one factor, then there will be two factors to be calculated. So if you divide with this known divisor, you will get a quadratic polynomial, and in the same way as we discussed in the sixth problem, you may calculate other two factors. I will find the quotient. So in the synthetic division method, you may find the quotient. See, first you have to write all the coefficients. See, that is 1 minus 23, 142 plus minus 120. You have to take care that after x cube there should be x square, after x square there should be x, after x there should be constant. If any term is missing, that means after x cube, if you are writing x, you are missing x square. So for that you have to write 0, its coefficient. So you know x is equals to 1, means x minus 1 is a factor. So first you have to write 0 for everything first. and add these two. 1 plus 0, 1. Multiply these two. 1 into 1, 1. Minus 23 plus 1, minus 22. Minus 22 into 1, minus 22. Plus 142 minus 22, that will become plus 120. So plus 120 into 1, again that will become plus 120. So if you add these two, you will get 0. Okay, and this is the quotient. When you divide a polynomial of degree 3 with a polynomial of a degree 1, you will get a polynomial of degree 2. That means this starts with x square, 1 into x square minus 22 into x plus 120. This is the quadratic polynomial after dividing with known factor x minus 1. For this you may calculate two factors since it is a quadratic polynomial, as we discussed in the sixth problem. Then total factors will become 3. In this case 2, we are going to get 2 and this is 1. Therefore total factors are 3. Coming to eighth problem. Eighth problem is also same. Using factor theorem, verify whether x plus 1 is a factor of the given polynomial or not. Very simple. You have to assume its name as p of x. You may assume as p of x or q of x or g of x, whatever it may be. P of x is equals to, see, 5x cube plus x square minus 5x minus 1. You have to verify whether x plus 1 is a factor or not. When a divisor will become a factor? When you get remainder 0, then that divisor will become factor of the dividend. Now I will check, I will find the remainder. If I get remainder 0, then I will say that x plus 1 is a factor of the given polynomial, otherwise not. Now what they are saying, what they are asking, x plus 1 means we have to place x is equals to minus 1. That implies to p of minus 1 will become the remainder. I will substitute x is equals to minus 1 in the given polynomial. 5 into minus 1 whole cube plus minus 1 whole square minus 5 into minus 1 minus 1. That is equals to 5 into minus 1 whole cube. Again that will become minus 1 plus minus 1 whole square will become plus 1, and here minus into minus will become plus. 5 into 1, 5 minus 5. Sorry, finally minus 1. That is equals to 5 into minus 1 minus 5 plus 1 plus 5 minus 1. See, minus 5 plus 5 cancel, plus 1 minus 1 cancel, that is equals to 0. That means p of minus 1 is equals to 0 means when you divide the given polynomial p of x with x plus 1, you are getting remainder 0. That means the divisor x plus 1 is a factor of the given polynomial. Coming to ninth problem, they have given two polynomials and they are saying that they have a common factor x plus 1. Factor, when there is the term factor, you have to understand that the remainder is 0. Okay, then you have to show that c is equals to 0 and a is equals to b. It's very simple. I am assuming the given two polynomials as p of x and q of x. Now that is, let p of x is equals to, what is that? P of x is equals to ax square plus bx plus c, and q of x is equals to bx square plus ax plus, I think it is c. Now they have a common factor x plus 1. Common factor x plus 1 means when you substitute x is equals to minus 2, your remainder will become 0. Therefore, given that x plus 1 is a common factor of p of x and q of x, therefore p of minus 1 is equals to 0 and q of minus 1 is equals to 0. Why? Because x plus 1 is equals to 0 means x will become minus 1. So first I am taking this one. See, I am substituting x is equals to minus 1, a into minus 1 whole square plus b into minus 1 plus c is equals to 0. In this case, minus 1 whole square will become 1 again. Therefore, a into 1 a, and plus into minus minus plus c is equals to 0. That means in this case you may write a plus c is equals to minus b goes to that side, that will become plus b, then this let it be 1. And in the second polynomial you are having remainder 0 when you put x is equals to minus 1, that is b into minus 1 whole square plus a into minus 1 plus c is equals to 0, remainder 0. Therefore this minus 1 whole square means again 1 into b, and this is minus a plus c is equals to 0. Both are equals to c, that means a minus b plus c is equals to b minus a plus c. On both sides you may cancel plus c, therefore this minus a comes to this side, therefore becomes plus a, and b, this minus b will become plus b, therefore 2a is equals to 2b. If you cancel 2 on both sides you will get a is equals to b. They are asking a is equals to b. If you substitute a is equals to b in either of these equations, in either of these two equations, you will get c value as 0. So it's very simple. Coming to 10th problem, factorize. They have given one polynomial in 3 variables x, y, z. Actually, this is the polynomial whose factors are to be found by using identity. So you discussed what are the identities and how they are useful in factorizing the polynomials. This problem is to be factorized by using the identity called a square plus b square plus c square plus 2ab plus 2bc plus 2ca, that is equals to a plus b plus c whole square. Now we have to write the given polynomial as a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Then find what are a, b, c. Then you may write it in form of a plus b plus c whole square. See, I am writing this 4x square as 2x whole square, right? 9y square as 3y whole square, and this 25z square as 5z whole square. Okay, and if you observe, this minus 12xy may be written as 2 into 2x into minus 3y. See, you may write this 9y square as minus 3y whole square. Why? Because I am writing minus here. Here you are getting minus, means this may be 2ab. In either a or b, one of may be negative, and also here you are getting minus, means in these two what is common? Y is common. That means y may have minus for it. We will write it. If it is not suitable, then we will change it. Okay, so that's why I am writing minus. Here also minus, see, plus 2ab, plus into minus will become minus, and minus, see, 2 into 5z into, okay, minus 3y. See, this is also plus. Again I am writing this yz as 5z minus 3y. Finally plus 2 into 2x into, see, 5z. So then it will become 2 to the 4 5z 20 zx. So I arranged the given polynomial as this. So 2x whole square means 4x square, minus 3y whole square means, for minus you have square, it will become plus, therefore 3 square is 9, and y square. See, this is in the form of a square plus b square plus c square plus 2ab plus 2bc plus 2ca, that is equals to a plus b plus c whole square. Here a is equals to 2x, that is equals to 2x a plus b. B is actually minus 3y plus c. C is plus 5z whole square. See, these are the two factors. Square means you may write it two times. X square means x into x, like that. This 2x minus 3y plus 5z into 2x minus 3y plus 5z. This is one factor, this is other factor. So this is the way how to factorize the given polynomial by using the identity, suitable identity. Coming to the 11th problem. 11th problem is also same as one of the methods we solved so far, but they use different terminology. Give possible values for L and B, where L is length and B is breadth of a rectangle. Whose area is this? See, area of a rectangle is multiplication of length into breadth. That means area is product of two factors. We have to find those two factors. Then first factor will become length and second factor will become breadth. So the area is equals to, this is question number 11. Area of a rectangle is equals to, area of rectangle is equals to 2x square plus 9x minus 5. You have to factorize. Actually this is obtained by multiplying length into breadth. Means you multiply two factors and you got this one. We have to find those two factors. So we have to factorize. What I said, you have to multiply the constant with the coefficient of x square, that is 2 into minus 5, that is equals to minus 10. You have to find the possible factors for minus 10, and if you add or subtract those possible factors, you have to get this plus 9. So I am writing 1 comma minus 10. If you multiply these two, you will get minus 10. Similarly, you may multiply 2 with minus 5, you will get minus 10. And what are the remaining? And plus 10 comma minus 1. These are the factors which are suitable to get minus 10. Therefore, if you observe 10 minus 1, you will get plus 9x. You may take this also, but you have minus for the bigger number. Therefore, you will get minus 9 here. Therefore, instead of taking this one, I will take this one. Therefore, 2x square, 9x may be written as 9x, 10x minus 1 into x minus 5. Now you got 4 terms in the polynomial. If you observe, the first two terms contain 2x as their common factor. If you take 2x, then I will have x inside the bracket from the first term plus 2 5s are. And if you observe, you don't have any common factor, means you have 1, that is minus 1. If I take minus 1, then inside it will become plus. Again you have x plus 5 as your common factor. Therefore, you will have 2x minus 1. Therefore, these are the factors of the given area of the rectangle. See, this will become length and this will become breadth. You may take different values for L. If x is equals to 1, then length will become 6. If x is equals to 2, you will get 7 as your length. So similarly, if you substitute different values for x, like in this L, you will get different values for B. So there are many more possible values for length and breadth for the given area of rectangle. In this way, you may calculate the various values of L and B. I hope you liked the video, you enjoyed the video. I hope this video is very useful to the students. If you like my video, kindly subscribe my channel and don't forget to press the bell icon. This gives me an immense pleasure and confidence to make more videos on different important topics. You will meet in another video. Until then, have a nice day. Thank you.